We're now going to enter into our unit about compounds and different types of bonding. The unit that we just finished was about the elements. We talked about how reactive they are versus others based on the periodic table. We talked about gaining and losing electrons. So now we need to talk about why they gain and lose electrons and why they're reactive and what happens when they come across each other. So you have three different types of bonding. You're going to have to be able to figure out what type of bonding is present based on the elements it's between, based on a few words that I give you, and their properties. So you have to be able to decipher these three. So you have metallic, ionic, and covalent. Now I'm going to let you know that metallic, the only time we're going to mention it is today. So therefore, you need to make sure you understand this and you get it. So metallic bonding is between a metal and a metal, which should make sense because it's metallic bonding. Key phrases or attraction. What causes that bond to happen? The valence electrons are mobile. Think about what the word mobile means. A mobile home, a mobile, automobile, it's all things that are able to move. So in a metallic bond, your valence electrons are able to move freely. This attraction is between the valence electrons and the positive cations the metals are forming. So literally, the valence electrons are floating around the cations as if they were fish in the ocean. So some key phrases: mobile electrons, sea of electrons, and that comes down to the analogy of the valence electrons are fish swimming through the cations. Delocalized is another fancy word they like to put in there. That means the same thing as these two things. It just means it's able to move. Now, the properties of metallic bonding is exactly the same as the properties of a metal. So high melting and boiling point, good conductors, malleable and ductile. So then we move on to ionic. Ionic bonding is between ions. That is why it's called ionic bonding. So we have two different types of ions that we mentioned. We have cations and anions. Cations are positive, anions are negative. We talked about that last unit. Or it's between a metal and a non-metal. So you have two elements on different sides of the periodic table coming together to form a bond. Now, since your cations are positive and your anions are negative, that is where we get the bond from. The ionic bond is the attraction between the positive ion and the negative ion. So the whole reason that this bond works is because opposites attract. That positive metal is attracted to the negative nonmetal. But when you put your ions together in the compound, the net charge has to equal 0. Net charge meaning the overall charge of the compound has to be 0. That's the only way they're going to be stable is if they cancel each other out. Key phrase you've got to know: ionic compounds transfer electrons. So the cation is giving the electrons to the anion. The cation is giving them away, the anion is taking them in. Now when this happens, you get a crystalline structure, high melting and boiling point, good conductors only, and I would highlight that word only, when molten or dissolved in water. Molten just means same thing as melted in a liquid state. So good conductors only in liquid state. If you take a grain of salt, it's not going to do anything. You put a grain of salt in the water, it will conduct electricity. So our next type of bonding, we went from metal to metal, metal to non-metal, so the only thing that's left is non-metal, non-metal, with our covalent bond. So covalent bond is the attraction between two nonmetals that share their valence electrons. Neither one of them wants to give away their electrons because they're nonmetals. So the only way they're able to put up with each other is by sharing. So covalent compounds share electrons. Again, there it is. And sharing is caring. C. Covalent caring. Sharing is caring. And since they are just nonmetals, the properties again are the same as the nonmetals. Low melting and boiling point, poor conductors, brittle when in a solid state. Okay, the next part of the notes, we're going to move into ions. In order to do this, we need to understand what electron dot diagram is, octet rule, and we need to go over ions again. So electron dot diagram, all it is the number of valence electrons represented by dots. The only rule that I'm going to have for you is that you can only have 2 dots per side. So we have to review, how do we find the number of valence electrons? So for instance, Rn, what group is Rn in? It's in group 18. Group 18, look at the Roman numeral, has 8. So therefore Rn has 8 valence electrons. So we're going to do 1, 2, 3, 4, 5, 6, 7, 8. 8 dots around. Again, the only rule is you can only have 2 per side. It doesn't really matter if yours look exactly like mine as long as it has the same number of dots. Hydrogen is in group 1, so it has 1 dot. Nitrogen is in group 15, so it has 5 dots. Again, you're just looking at the group number, and if you can't read Roman numerals, then just take off the 1. So group 13 has 3, group 15 has 5. Okay, magnesium is in group 2, so 1, 2. Aluminum, group 13, so 1, 2, 3. Argon, 2, 3, 4, 5, 6, 7, 8. Potassium, 1. Bromine, 1, 2, 3, 4, 5, 6, 7. Now helium. This is the one you need to mark in your notes and understand. This is the exception to the valence electrons. Helium only has 1 energy level, and the first energy level can only hold 2 electrons. So therefore, helium only has 2. Yes, it's in group 18, but remember it's only on energy level 1, so it only has 2. I'm telling you that half of you will probably put 8 when this appears on the test. So make sure you're not one of those one of the half people. Fr, francium, 1. Take a second and review. Now, the octet rule. Octet. The prefix oct means 8. So this rule has something to do with the number 8. In forming compounds, atoms tend to achieve the electron configuration of a noble gas. Remember, your noble gases are stable. They're the most stable elements on the periodic table. So all the other elements are trying to achieve that same stability. To get there, that's why they either lose, share, or gain electrons. So remember, octet rule is to have the electron configuration of a noble gas. Now, in most cases, that means 8, hence the reason why it's called octet rule. But remember, helium here only has 2. So there's plenty of elements that are happy with just 2 valence electrons. So when I ask about this rule, this is going to be the key answer here. I will throw that number 8 out there, and that will be wrong. Then we have a review piece here. Metals lose electrons. Therefore, they are cations that are positive. When you lose something negative, you become positive. Nonmetals gain electrons, therefore become anions, which are negative. Okay, you now have a chart in your notes. This chart, I will go over a first couple together and then pause the video, try them on your own, and then check your answers. If you do not understand something, please come with questions tomorrow. So, what you have here are some elements on the side and a bunch of stuff that I need you to answer. Now, most of this is review up until we get to here. Okay, these last 3 columns are going to be the new stuff. So first, sodium, its atomic number is 11. So the number of electrons, meaning total electrons, is 11. Guess what's back? Electron configuration. Third time here, you've got to make sure you understand electron configurations. If not, you need to stay after school with me or before school. Electron configuration, we're going to go all the way to Na, so 1s2, 2s2, 2p6, 3s1. Group number, it's in group 1. Since it's in group 1, how many valence electrons does it have? 1. So then we do the electron dot diagram, it's just Na with 1 dot. Is it a metal or a non-metal? So again, is it to the left of the staircase or to the right of the staircase? It's to the left, so it is a metal. Now looking right above this, metals do what with their electrons? They lose. Okay. The next 3 columns are based on the information you just gave me. I want to know the number of electrons gained or lost. To do this, you need to look at the number of valence electrons. Your metals, make sure you understand this, metals lose all of their valence electrons. Let's say that again. Metals lose all of their valence electrons. So since sodium has 1 valence electron, it's going to lose 1 electron. You might want to make a note of that. Metals lose all of their valence electrons. Now, the ion symbol. All you do is take Na, how many electrons it either lost or gained, so in this case, 1, and then tell me whether it's going to become positive or negative when it loses that 1 electron. If you lose an electron, you become positive. So it becomes Na 1+. Then, the ion electron configuration. This simply is taking this and doing what you just told me happens here. So Na told me lost 1 electron. So when you do the configuration, you need to lose 1 electron. So in this case, you're simply going to lose that outer energy level. So the 3s1 goes away. So you're ending up with 1s2, 2s2, 2p6. An ion electron configuration should always resemble a noble gas. If it does not resemble a noble gas, then you are wrong somehow. So just to go back real quick, most of this is review. Metals lose electrons. They lose all of their valence electrons. Here you just show how many lost, positive it's a metal, and then simply get rid of the valence electrons. Now, the next example we have is a non-metal. Non-metals are completely backwards when we come to those last few columns. Sulfur is, the atomic number is 16. So the number of electrons, 16. 1s2, 2s2, 2p6, 3s2, 3p4. Okay, group, it's in group 16, sorry. So how many valence electrons does it have? 6. Remember, if you don't know the Roman numerals, simply cover up the 1 and you got it. So the electron dot diagram is sulfur with 6 dots. Is it to the left or the right of the staircase? It's to the right, so it is a non-metal. Since it's a non-metal, will it gain or lose electrons? It will gain. Okay, now the question is, how many will it gain? Now remember, everything is trying to be a noble gas, which in most cases has how many valence electrons? 8. So therefore, if we have 6 right now, and it wants 8, how many is it going to gain? 2. So your nonmetals gain enough to have 8. So the nonmetals gain enough to have 8. Your metals lose all of their valence electrons. So right now you're starting off with 6. Therefore, 6 plus 2 gives you 8. So then the ion symbol is simply S2, and it's a nonmetal. It has gained electrons, so S2 negative. Then all you do is take that electron configuration and add those 2 electrons to the very end. So instead of being a 4 here, you do 4 plus 2, which gives you 6. So 1 S2, 2 S2, 2 P6, 3 S2, 3 P6. Now take a second and try to complete the table on your own. Now take a second and actually check your answers. If there's anything that you got wrong or you have questions about, please make sure you ask them in class. Okay. Our last thing. I know this is a long video, but hang tight. Our last thing is common ion charges. We already know our group numbers. 1, 2, 3 through 12, 13, 14, 15, 16, 17, 18. You know that your metals lose electrons and your nonmetals gain. So that's what this is pointing at. Your metals lose, so up to this point, the staircase, they lose, and then your nonmetals gain. The thing you've got to remember is a pattern. You may want to write this on your actual reference table, so when we do our work, you understand where all the numbers are coming from. So since they all have, group 1 all has 1 valence electron, they're all going to form the same ion charge because they're all trying to be a noble gas. And to do this, group 1 has 1 valence electron, so therefore it loses 1 electron and becomes 1 plus. Group 2 has 2, so it becomes 2 plus. Group 13 has 3 valence electrons, so to become happy, it loses 3. 14 doesn't form an ion. Typically, those are in your covalent bonds. 15, we transfer over to our nonmetals. Nonmetals in group 15 have 5 valence electrons. They want to have 8. So what will get us to 8 if we have 5? 3. So everything in group 15 has a 3 negative charge. All the nonmetals in group 16 have a 2 negative. 17, they have 7. They want 8, so they need 1. So 1 negative. Group 18, 0. So the pattern is simple. 1, 2, 3, skip, 3, 2, 1. Count up, skip, count down. These will be extremely important for the next lesson.